ASEAN Tech Forum. This is our SDA Access Bootcamp. Now we are taking our journey forward and trying to discover edge switches, and for that we are going to utilize a feature called LAN automation. LAN automation can help you build underlay network without any manual intervention riding on PnP. I have done a PnP video before, so link is in description. Please go ahead and watch that video. This document is a must-read document. Do not attempt your LAN automation without reading this document. LAN automation is a four-step process. Step 1 is plan, design, discover, and provision. So you need to plan how your edge network will look like, 2 tier, 3 tier, and then you decide on a seed device. Once you decide on seed device, provision is a two-part, start and stop. Once you start LAN automation, DNAC pushes some temp configuration, upgrade the device, discover the device. When you stop, it does something very beautiful. That means it convert layer 2 to layer 3, and that's the very much appreciated intelligent part. Okay, seed device, you can pick any of your distribution switch as a seed device. It can be like connected to your edges, maximum 2 hop. PnP agent. So PnP is the underlying strength or vehicle for this LAN automation feature. As you can see, PnP agent is a Cisco Catalyst switch with factory default setting. Switch leverages the built-in day zero mechanism to communicate with DNS center and support integrated PnP server function. DNS center dynamically builds PnP profile and configure that. And we will talk about PnP more when we actually look into the PnP logs. These are the several design options, constraint, limitations, everything is listed here. So make sure you read this document carefully. It also talks what happens if LAN automation fails for some reason, how to recover from that. And you will see that we actually ran into that problem, and I purposely put that part in this video so that you know what to do in failure situation. All right, I'm not going to read the document. It has so much useful information, but the beautiful part is when you stop the LAN automation, what happened then? And that we will discuss or see when we do the demo. Who can be seed device? All the lists are here, so make sure you are aware of constraints. IP pool for LAN automation are created. First, creating global pool, so we will create a global pool. One part of IP pool is reserved for temporary DHCP server. Second part is used for link configuration between connected device and participated in discovery session. Third part is used to allocate single IP address per device. So after LAN automation, you will see that you have underlay built. Also, you have a loopback address configured for your edge devices. Make sure when this is how you prepare for PnP. So make sure you don't have any VLAN configured in VLAN database. You don't have any certificates and all those things. So make sure it's you start clean slate, and you can use those commands to initialize your devices. Now it's a high level LAN automation prerequisite. Before starting, make sure that you meet the prerequisite. That means seed device will become a DHCP server with a DHCP range specified in DNS center. That means you have to specify your IP pool. PnP device comes up without a running config, so make sure you clean up your device. VLAN 1 gets IP address from seed device because it becomes a DHCP with option 43, and you will see what goes into option 43. Option 43 will have DNS center IP address. PnP devices pull the configuration from DNAC. Underlay gets configured automatically using the IP pool assigned by DNS center. This step is performed as soon as you stop LAN automation. PnP continue. PnP device get associated to the site and DNS center added to the ICE network devices. PnP device will be configured with a host name, whatever prefix you define, it can use that. Any devices in the fabric can act as a seed device. LAN automation works for device maximum 2 hop away. Make sure your out of band management interface, which is gigabit Ethernet 0/0, part of VRF, management VRF is not configured. Otherwise, you will see that you are getting a DHCP probably on that interface and it will abort the PnP process. This is our setup currently looks like. We have a fusion which is outside fabric. We have a border node already configured, and this GBR device we will characterize it as a border. Though since we have not built the fabric yet, so there is no role associated with that, we are going to use this device as our seed device. When you go to your device provision, you can find the option of LAN automation and you will see what goes inside this. You can choose a file like you want. If you want to do a hostname prefix, that means you can do a large number of LAN automation in one go. Let's see, it will give you a sample file so that you know what is the format to use. Basically, it's nothing, just define your serial number, define your prefix, and when DNS Center do the discovery, it is going to use that prefix and add a number with that discovered device. So you can say edge, and whatever device DNS Center first chooses, it will mark it as a edge 1, edge 2. Also, image upgrade is part and parcel of LAN automation, but if you want, you can disable that process and upgrade the image later on. All right, this is my seed device. I'm on the SSH of seed device. Let's see if we have any, what is my CDP look like. So I have two edge devices connected. They are directly connected on port number 39 and 40. Let's see if we have any ISIS neighbor. As you can see, there is no ISIS neighbor right now. It's just physical connection, layer 1 connection. Let's look at the interface configuration. No configuration. This is a default interface. And these are my edge nodes which we are trying to discover as a part of LAN automation. So now we are going to do prepare edge switch for LAN automation. That means we are going to remove certificate, VLAN database file, everything just like we did during device discovery. So this is the event applet I'm going to run. What this event applet does, as you have seen in previous video, it just remove all the configuration, write erase everything, destroy certificate and reload the device. Make sure when you are doing any kind of like a PnP or LAN automation, you just reload, clean up the device, reload, and don't touch your console. Otherwise, PnP process will be aborted. So I'm going to do the same process, repeat the same process on both my edge switches, because we are planning to bring in two edge nodes as a part of LAN automation. This is going to be a long video because we'll see a failure scenario as well. So be prepared to watch it till the end. There is a lot of good information coming up. Now first look at IP address pool. Have we defined a IP address pool for LAN automation? You can see LAN automation type is LAN. It's not generic pool, and I have defined a IPv4 subnet 192.168.13.0/24. That means it can accommodate 256 IP addresses. Out of those 256 block, it will be broken into multiple things. All right, so as you can see, I'm just going to advertise this LAN automation subnet to outside so that my DNS center will have reachability to this subnet. Make sure you do this. You don't have to do this manually in newer releases. DNS center does it automatically for you. But make sure you have this subnet, LAN automation subnet, defined and advertised in your BGP, so that DNS center can have reachability. All right, we are going to now clean up both our edge switches so that they can be reloaded and they'll just sit in PnP wait mode while we initiate our PnP or LAN automation from DNS Center. Right, we are going to run this event manager script on both edge nodes. All right, now we are ready to run our LAN automation. Primary site, choose the site where you have your seed device. Choose the device, which is your seed device. Discover device site, where you want to put your discovered device, and then choose ports of primary device or the seed device. So I'm going to choose ports where my edge switches are connected, and as you have seen from show CDP neighbor, they are on port number 39 and 40. Pretty straightforward workflow. Discover device site, I want to put them in the same site where my seed device is, but you can choose to put something else. IP pool, so this is the IP pool we configured earlier. Select that IP pool, the LAN IP pool. You can enable multicast as a part of LAN automation, and as you can see, advertise LAN automation summary route into BGP. That's what we did earlier manually, but you can make it as a part of LAN automation workflow. Simple. All those simple information you have to put. That means you are doing plan and prepare. Hostname, I gave a prefix called edge, and whichever device is discovered first out of those two edge, they'll be marked as edge 1, and then the next will be marked as edge 2. Looking good. You can track LAN automation progress status by going to LAN automation status, and it will take some time. So be patient. Don't touch edge devices console, but you can watch things here in DNS Center, or you can see what configuration is going into seed device. As you can see, this is my seed device. DNSC pushes a DHCP range with option 43, and we will talk about the format of option 43 and option 60. So this is the information goes into seed device. It configure interface VLAN 1 and assign an IP address from LAN automation pool, and then it try to as my edge switches sending DHCP discover messages, it seed device is going to be going to function as a DHCP server, and it will pass on the IP address as well as option 43. The option 43 has IP address of DNS center, and that way my edge device can reach out to DNS center. As you can see, we also have the interface configuration. Right now, port number 39 and 40, they are configured as access port and put them in VLAN 1. When we stop LAN automation, you will see that those layer 2 or access port, they'll be converted into point-to-point layer 3 link, and you will have a router ISIS process built on top of that. That happens when you actually stop the LAN automation. So two-step process. Once you start DHCP configuration on seed, devices get DHCP IP address. They get to know who's the DNS center server. So basically that discovery part. When you stop LAN automation, then the layer 2 converted into layer 3, and that's how your underlay is built. So as you can see, that was a summary, and this is my process going on. As you can see right now, no devices completed C device configuration phase. That means C device has got DHCP configuration, but there is no devices discovered yet. Looks like my edge devices are reloading and they are coming up. So the ports are up on C device. And now edge will try to do a PnP process. That means it will start sending DHCP broadcast or DHCP discover messages, which will be received by C devices. Please be patient here. As you can see, gigabit Ethernet 0 bar 0, and it's trying to reach out and get an IP address on that. So make sure your out of band interface or gigabit 0 bar 0 is not connected. Please do not touch the edge console. You can watch what is going on, but don't press any keystroke. Let's refresh and see. Still, discovered devices are 0 and completed 0, but seed is provision. Now you can see there is one device in progress, and these are the different states. So this is in progress, and that is named as Edge 1 by DNS Center. Device is already claimed. Image upgrade will be skipped for because it is not in bundle mode. You can manually update the image using swim after LAN automation is complete. So this is the sequential things what is going on. Device is discovered. They will be try to do a image upgrade, but since we are in bundle mode and I have talked about bundle and install mode, in a dedicated video, a separate video. The link is again is in description. Please go and watch that video. So this is the entire flow of LAN automation. Now we have in progress 2. That means the second device is already discovered, and we can confirm that going into Edge console. So you can see it is getting PnP information from seed device. Right, to discover devices. So we ran into an error. What happened? PnP device could not be provisioned due to PnP claim error, failed to install image on device. Now write erase reload the PnP device. So LAN automation process failed. That means for some reason PnP cannot claim this, and this is the error we are getting, failed to install image on device. So discovery was success, but provisioning was not successful. Now let's hit stop the progress, and again stop can take some time, so be patient here. But keep in mind LAN automation has failed. Now we have to clean up and see what we can do to reinitiate the process. These are my edge which were discovered, and as I try to enter that, you can see the mode is in bundle mode. Again, for other switch also mode is in bundle mode. So, but as you can see, bundle mode and proven to be a showstopper here. Many a times you will receive a device from and the factory default mode or the default version is in bundle, and you may run into this problem. My C device still have DHCP configuration. Let's see, when we stop, DNS Center should intelligently roll back this configuration. Otherwise, we have to clean it up manually. That will be sad, but let's see what happens. All right. Now, since this device was already discovered, that means it has certificate and other things available. So if you want to rediscover that device or make it ready for another PnP, you need to again reinitialize that, and that's what we are doing here, deleting configuration, deleting VLAN.dat file, etc. And this configuration is available in LAN automation documentation. Save configuration, no. Reload the switch, yes. And we have to do the same thing for both edge nodes. Yeah, I would have skipped the part where LAN automation is failing, but I don't want you to panic if for some reason your LAN automations fails. So it's always worth to know how to roll back and go to a known good state. So since LAN automation did a partial job, you can see I have two switches, they are in error state, and you have to clean this up before you reattempt your LAN automation. You can say reset or you can say delete. Delete would be a best option here because we don't want to keep current claim parameters. We want to like start from fresh and see not eligible for deletion. Sometime you will run into this kind of sticky issues. So give it some time, come back and try to delete again. It should work. Since we stopped our LAN automation, we still see the DHCP configuration on C device. Go ahead and delete that manually. So what I'm doing here, I'm going to untag the golden image for my edge nodes because I do not want to do a image upgrade as a part of LAN automation. Hence, I'm going to just disable that golden image, and now I'm ready to re-attempt LAN automation. Some of the information is preserved, so you can simply use those information. Here we are, disable the golden image, and now we are ready to perform our LAN automation. It started, network orchestration starting. Now we can check the LAN automation status again from DNA center, and we can also watch from CLI to C device CLI. The same set of DHCP configuration will be pushed this time. You can see seed is provisioned just like before, and we are waiting for discovery to happen. You can see we have received the DHCP configuration from DNA Center. It has option 43, it has option 60. As you can see, now we have two devices discovery in progress. That means seed device has made contact to edge, and edge in turn made a contact to DNS center, and DNS center is trying to DNS center PnP is trying to claim the devices. And now you see the host name is edge 3 and edge 4 because LAN automation has already used edge 1 and 2, though the process failed. Reserve subnet, so it is using that subnet and assigning an IP address on both devices. Claim device, the first device is claimed, generating config file for that device. Discover devices 2, status is in progress. And this is our edge device console. As you can see, it has got the information option 43 from DNS center, and it has adjacency up in VLAN 1. Mind it, you have IS-IS adjacency today, but that is in VLAN 1. That means your seed device is running IS-IS, your edge devices are running IS-IS, but they all are running IS-IS on interface VLAN 1. But that's not what we want. We want a layer 3 underlay. And this is while LAN automation is in progress, right? So edge device is discovered, made a contact to DNS center, and DNS center has pushed the configuration, day 0 configuration. As a part of that, the seed and edge, they are running IS-IS, but right now at this state, which is a transitory state, they have a IS-IS adjacency, but that is on interface VLAN 1. Now, as soon as it says complete, it's a good time to go ahead and hit stop button on LAN automation, and that's the engineering marvel happen here. As soon as you hit stop, there is a backend script that will configure, that will convert the layer 2 to layer 3 and advertise them into IS-IS and clean up the interface VLAN 1. So this is the transitory state what you see on my screen, where your edge 3 and edge 4, they have a IP address on VLAN 1 and it is running IS-IS. Now stop LAN automation to convert layer 2, which is my connected switches, connected interfaces 39 and 40, to layer 3. And you can trail the logs, all the logs here. The device is already available in inventory at this stage using a loopback address which was assigned from the IP subnet which we defined earlier. You can see loopback address is assigned 65 and 70. Now we are hitting stop in progress. So that's why you see stop take that much of time, because stopping is also another milestone. When you stop the LAN automation, things happen the back end, and that's our final product. That's the end result we want. We want to build our underlay IS-IS with our seed devices or distribution devices. Now you can see this is my interface on seed device 39. So 1039, 1040. Initially it was layer 2 interface, part of VLAN 1, and now once we started stopping LAN automation, that interface is converted to layer 3. It has IP address, it is IS-IS point-to-point interface, and advertise into IS-IS process. That is the strength of LAN automation feature. You do only very basic things, very minimal things. Define your IP pool, define your seed device, and that's it. Just do a start and stop. Your entire underlay will be built. So I'm doing that with 2 switches. I see immense benefit. Think about the scale. If you are doing it for entire floor maybe. It's so easy to do that, and it is not uh, erroneous. It's there is a no human intervention or planning running, so there is a minimal chances of error. LAN automation, stop in progress, completed LAN automation. That's what you want to see. Completed final sync, completed LAN automation. Starting device cleanup, that's where we roll back VLAN 1 configuration. If I do a clear screen and check interface VLAN 1, no IP address, nothing there. So rollback happens successfully. See if DHCP configuration is rolled back. Yes, you can see now there is no DHCP on my C device. Let's check the connected interface. And I'm looking at the wrong interface. That should be 39 and 40. Yes, voila. You see, we have an IP address from the subnet we defined, and it is advertised into IP router ISIS process. At this point of time, my underlay is built. Devices are part of DNSE inventory assigned to the site wherever we want to assign it. Completed 2, discovered 2. Everything looks good here. So if you are confused why LA failed in first time, because my show version, the mode was bundle and DNS Center was trying to upgrade that. It couldn't do that because the mode was bundle. To work around that, what we did, we disable or uncheck the golden image so that DNS Center doesn't attempt to upgrade, do a image upgrade, and it skipped that step, and it is kind of progress ahead with that. Now my device is in inventory. I just want to make sure that it has all the credentials. It has CLI credentials, it has SNMP credentials, it has netconf enable. So that's what I'm doing here. I'm applying credentials to that. Enable netconf. Checking the basic configuration or day 0 configuration. And as you can see, we didn't assign any host name or anything, but it is there. This is my PnP log. If I see enough interest in comments, we can do a deep dive session on PnP, how it works. But as you can see, this is the day 0 configuration, which comes after PnP. So DNS Center has pushed the TrustPoint DNSCA certificate. That happened when DNS Center claimed the device. You may not see any telemetry or SDN infra certificate, so you have to apply telemetry. But uh, at basic level, it looks good. It has reachability with DNSE. It has the secure communication with DNSE, and all the SNMP credentials, NetFlow, everything is configured. Same thing with second edge node. Pretty much same configuration. IP addresses will be different, obviously. So now my edge switches are ready and available in DNS Center. We can make it part of Fabric. Check the loopback addresses 13.70 for edge 4. This is our DNS Center CLI. Let's see if we can SSH two newly discovered edge nodes, and as you can see, we are running into the same issues where SSH keys mismatch happen. So it as you know, this is a known issue and it will be taken care as we upgrade the software version. All right, I'm applying device credentials here just to make sure. Enable netconf. A lot of telemetry settings, they rely on netconf, so make sure you have netconf enabled for your devices. So next I'm going to do a one-shot install and change from bundle to install mode. I have shown you that in previous video, device discovery video, and I'm going to repeat the same thing here. So edge devices are looking good. LAN automation is successful. Sometimes it take a little bit to. All right, so devices are 0. Let's look at the inventory. Okay. The setting was applied as global and we don't have any devices in global. They were part of site edge 01. And here you can see we have that in DNS Center and they are in managed state. LAN automation. PnP device get associated to site. PnP devices will be configured with the host name. You saw that. LAN automation for devices which are 2 hops away, and make sure your gigabit 00 is not configured. Now the final piece, we are going to go to ICE where these devices are already added and change the attribute to SDA. So we are going to change the device type to SDA so that the policy set SDA will take effect for this device. So make sure you do that because we have created a custom policy set as you have seen in previous video in ICE policy set video. And we do the same for second edge switch. Change the device type to SDA. save, so that any client coming to this network device trying to authenticate, it knows that this device type is SDA and it will use SDA policy set. So we are done with LAN automation and added it to ICE as well. Let's go ahead and build Fabric next. So thank you for watching and staying with me. I hope you're liking the SDA bootcamp so far. If you have any questions or comments, put that in description or come join our Discord discussion. Thank you.